This grainy simple line is one of the most iconic photo in science, captured in a cloud chamber in 1932 by Carl Anderson, for which he also won the Nobel Prize. It's the first ever image of a positron that proved the mirror image of matter. Antimatter wasn't just a science fiction dream, it was a reality. But look at this now. It looks like a normal delivery truck to you, but inside this truck was the rarest, most expensive, and most volatile substance in the known universe. In March 2026, scientists at CERN put antimatter in a truck and drove it down the road, and it's being called the Antimatter Express or antimatter in motion. And while it was only a 4 kilometer 20-minute drive, it just kicked off a brand new era of physics. Today we are going behind the scenes of the most dangerous cargo on Earth to find out why they were moving it and how it didn't annihilate, and how it might finally explain why anything or everything exists at all. Alright, let's rewind for a second so we are all on the same page. This right here is the iconic image of the first positron ever detected. Carl Anderson, working at Caltech, basically proved that antimatter was real just after 1 year it was theoretically predicted. It was a huge win for physics back then. Think of antimatter as the evil twin of the regular matter. Same mass but opposite charges. But here's the catch. When they touch each other, they annihilate. They vanish in a burst of pure energy, mostly gamma rays. It's the most efficient energy release in physics. This makes it impossible to store it in a jar, and if it touches the wall, boom, everything around it is gone. Normally, to keep antimatter alive, we use massive magnetic traps in a vacuum. But today, for the first time in history, we transported antimatter, actual antiprotons, from one spot to another inside a regular truck, because there is a problem. CERN's antimatter factory is noisy. Huge accelerators create magnetic interferences that messes with delicate measurements. Scientists want to move antimatter to a quieter lab or even a different university. They built a 1-ton portable container for this. It's a masterpiece of engineering. The liquid helium keeps it at absolute zero, and the superconducting magnets suspends the particle in a perfect vacuum, so they never touch the sides. In March 2026, they loaded 92 antiprotons into this device and put it in the back of a truck and drove for 20 minutes around the CERN campus. When they plugged it back, all 92 were still there, safe and sound, not a single annihilation. They are calling the project the base step, symmetry test, and experiments with portable antiprotons. And yeah, that little road trip marks the start of a whole new era in the particle physics. But why go through all this? First, money. Antimatter is the most expensive substance on Earth, roughly $1 trillion per gram. But the scientific cost of not studying it is even higher. According to the Big Bang model, the universe should have created equal amounts of matter and antimatter. They should have cancelled each other out, instantly leaving a universe of just light and something we don't know even. No stars, no planets, no you. But we are here. This means there is a broken symmetry, a tiny flaw in the laws of physics that allowed matter to win. We are the leftovers of a cosmic war. We have now entered what physicists call the precision era of antimatter research. Tiny differences could explain why matter won, why antimatter lost, and the last few years have given us some jaw-dropping clues. Now definitely we are still nowhere near using antimatter to fuel a starship. That's a pure science fiction for now. But we are getting closer to cracking the code on why the universe didn't just annihilate itself into nothing. Well, here's what we have learned recently. Like, does antimatter fall down like regular matter, or does it fall up in some anti-gravity way? Well, the answer is no. CERN confirmed that antimatter falls down at the same rate as the regular matter. So, no anti-gravity. It's ruled out. Then last year, the LHCb collaboration at the Large Hadron Collider dropped a bombshell. They looked at the decays of lambda B beauty barons, the heavy cousins of proton made with a beauty quark. Comparing them to their antimatter versions, they found a 2.5% difference in how often certainly decay paths happen. That's a clear sign of charge parity, CP violations, meaning the laws of physics treat matter and antimatter slightly differently. It's small, but it's real. And it's one of the best hints yet ever that matter had a survival advantage right after the Big Bang over the antimatter. In 2024, the AEGIS collaboration achieved something incredible. The world's first laser cooling of positronium, that exotic atom made up of an electron and a positron. The positronium usually annihilates in a fraction of a microsecond, but by cooling it from 380K down to 170K with a custom Alexandrite laser, they slowed down everything and gained a real control over the annihilation process. And then there is PUMA, the antiproton unstable matter annihilation experiment. They are using antiprotons to map the outer layers of radioactive nuclei by watching where annihilation happens. The ratio of particle produced reveal the neutron skin thickness, the data that directly help us to understand neutron stars, pulsars, and magnetars out in the space. Now, for the first time, we are linking tiny lab antimatter experiments to the physics of the most extreme objects in the cosmos, all without leaving the Earth. All of these breakthroughs happened in just last couple of years. We are doing the precision measurements with the real antimatter particles, and now with this real truck transport success, every new portable trap shipped out is another step towards solving the ultimate puzzle, the existence of everything.